Hi, I'm Kian, and I'm going to show you how to solve this physics problem including motion using calculus. So we have a ball that has the acceleration given by an equation 24t squared, where t is the time in seconds, and we're given that the initial velocity of the ball at t equals 0 is 18 meters per second. Now we need to find the final velocity at t equals 3 and then the net displacement from 0 to 3. So you have to know our kinematic equation. So we have to know that the final velocity is the initial velocity plus acceleration times time. But in this case, the acceleration is not a number, it's an equation. So basically, the final velocity we need to find is the initial velocity, which is 18, plus, and then the change in acceleration. So actually, not the change or the kind of the displacement in acceleration. So we have to take the integral, and then because we have to take it from time 0, which is the initial time, 0, and then up to the final time. In this case, we have given the final time, which is 3, of the acceleration function, which is in this case is 24t squared. And dt, and what we need to do is that evaluate this. So integral of 24t squared using the power rule is 8t cubed from 0 to 3, and this would be 3 cubed 27 times 8 is 216, plus 18 is 234 meters per second. So the final velocity is 234 meters per second. Now, for part B, we need to find the net displacement, which is basically like delta x, or the whole distance traveled. So I'm going to write it as delta x. So basically, we have to know what position, acceleration, and velocity. So we know that the change in position is the velocity function. So if we find a velocity function and take the integral, we can actually go back to the position function, and then we can add up all those values on the interval of the position to find the net displacement. So what we need to do is that we have to actually integrate from the interval given 0 to 3 our velocity function. But what is our velocity function? We have here 18 and then plus, and then we have to integrate 24t squared, because if we say like we don't have these upper bound and lower bounds, if we integrate 24t squared, you actually get 8t cubed. So we have 8t cubed here, and then dt. And so we have to just evaluate this integral, and what we get is 18t plus 2t to the power of 4 from 0 to t, and this would be 54 plus 3 to the power of 4 is 81, times 2 is 162. So the answer would be 216 meters. So this would be our delta x. And that's it. Thanks for watching. Please watch my other videos, and goodbye.